Sine x over cos x. You're going to divide. And then what's sine x over cos x? And then doesn't this look like advanced math now? That's it. That part there, 2 steps was extension 1. You guys got to understand that so you don't say extension 1's bad, right? Tan x now. X equals, what's inverse tan of 1? 45 degrees. Then you do your all stations to central. Where is tan negative? 180 minus 45. 360 minus 45. And then convert it. 2 marks in extension 1 now. Not bad. We would take that, don't we? Boom, boom. Good. Obviously B, you would do the same thing. B, you would do the same thing. So I'm not going to do B. Leave that for homework. Because why would you want to do it again straight away? Let's do C. Okay, that looks weird because now one's a double angle and the other one isn't. So we can't divide it. What do you do with C? Think about it now. Sine 2x equals?
2 sine times cos
X. Try to say x's as well.
Oh,
2 sine x cos x. All right, so C. C. 2 sine x cos x equals cos x. Now this is where the confusion comes in. Because of what I did in A and B, people think, okay, we should divide cos x. Problem is, if it cancels itself out, you got rid of an answer. So you know how right now, if I divide by cos, I'm about to divide on the left-hand side. I would also get rid of cos. That's bad because you got rid of one answer. So you don't divide. You only divide if you're going to get tan specifically. But if I divide on the left side, what happens? You only get 2 sine x equals 1. You didn't get tan. You only divide to get tan. Does that make sense? So you don't divide. So if you don't divide, what am I going to say to do at this stage? Bring it over. Now you will bring it over now. Why would you bring it over? Because you want your x's on one side. That's your general logic. Then what would you do at this stage? Factorize. And then again, this kind of looks like advanced math again. What do you make each bracket equal to? When it's factorized, make it equal to 0. You factorized. So think of it like this. If you've got 2 brackets equal to 0, what does that mean about each bracket? Either this guy equals 0 or this guy equals 0. True?
Yeah.
So same thing. If you've got 2 brackets equal to 0, it's either cos x equals 0 or 2 sine x minus 1 equals 0. And then go, finish it off now, and we'll check our answers. How do you read impressions?
No.
Okay, Inverse cos of 0 should just be 1, yeah, it should be 90. So x equals 90 and 270. Yes. The other one, you plus 1, divide by 2. I don't think I need to go through that still. I hope I don't. X equals 30. All stations are central, 150. And then the answer says 0 to 360. I think we're done. Just change them to radians. Pi on 2. There should be 3 pi on 2. Yep. 3 pi on 2. That should be pi on 6. That should be 5 on 6. Just check it. Yeah. 5 pi on 6. How many marks? 1, 2, yeah, 4. 4 marks. So 1 mark for the double angle of sine 2x, 1 mark for pretty much bringing it over and factorizing, 1 mark for each one to solve each. So 4 marks altogether. What do you think? It's okay, right? You'll get used to it. Okay, but it's okay. It's all right. All right, pick one out of whatever's left now, because the rest is just pretty much repetition. So wait, let's go back. It's either going to be tan x, like A and B. So that means when there's only one sine and one cos, one sine, one cos, or it's just going to be like these, which is bring it all to one side, factorize and solve. So go, give me one now. Whichever one you guys like. D, E, F, G, H.
D.
D. Let's go. Sine 2x, we're going to do D, equals sine squared. Sine 2x equals sine squared x. Sine 2x equals?
2 sine x cos x.
Equals sine squared x. What would you do at this stage?
Change sine squared. Bring it to the other side. Bring this side.
One sec. 1 minus cos squared. Yeah, no, you would have failed it. I'll do what you said, just so you can see what would have happened. Sine squared, and do what I was doing right now. Try to forecast what's going to happen eventually, when you get more and more practice with it. Sine squared, if this is wrong, but if I change it to 1 minus cos, not always wrong, just wrong in this case. So see, if you had said it maybe for F and G, let's say, if it was cos 2x, if you had said, Sam, change it to that, I would have said yes, probably.
Okay.
Right? So not always wrong. So just so you know, but I'll show you why it's wrong in this case. So 1 minus cos squared. The left-hand side is 2 sine x cos x. If I usually see cos squared and a number and then another term, what am I thinking? I'm probably thinking of trinomials, quadratic formula, whatever it is. Because cos squared, then I've got another x, then I've got a constant by itself. Does that make sense?
Yeah.
If I'm thinking of quadratics, this needed to be cos squared, tick, a constant, tick. This needed to just be cos. It can't have a sine x there. So it needed to look like this, in other words. Cos squared x plus 2 cos x, let's say minus 1, equals 0. Yes, that's it. That absolutely fine. You could have solved. The fact that I've got sine x there as well is annoying. You can't get rid of it. Because then you would have said, change cos squared to 1 minus sine squared. Then it would have all been in terms of sines. But then cos is still going to be there. You see that little issue? All right. If this question actually was cos 2x equals sine squared x, you're actually probably right. So you probably needed to do what you just said. All right. Back to what we were saying. Yes, you would bring it over to the left-hand side. So 2 sine x cos x minus sine squared x equals 0. What do you do now? What do you do now? So you would write sine x equals 0, but then can you see again, this looks pretty annoying. How do we solve this guy? 2 cos x minus sine x equals 0. It's not like what we just did above. I just want to show you. Look at this one. This one was 2 sine x minus 1. So I plus the 1 divided by 2. This one's got a cos and a sine. What the? Cos and a sine. What do I do?
To make it 10.
Done. So you see, sometimes they can be hidden. Just got to be ready for it. All right, here we go. Sine x equals 0. That's the one that I said is going to have 3 answers. Because there's 0. Then you would have done 180. But don't forget, if you ever have 0 as an answer, 360 is always going to be there. Because you can just add it. All right, this guy, as you guys just said, you have to make it into a 10. So 2 equals 10x. Because you divide by cos. And then inverse 10 of 2. X equals 63 degrees. And then again, all stations to central, 180 plus 243 degrees. Now I'm going to leave it at that. I'm not going to change them to radians. That's fine. I'll stop the recording.
Is that 243?
Yep, 243.